everyone. In this next lesson, we're going to apply two-step equations to solve real-world problems. So we're going to take everything that we've learned so far about two-step equations and apply it to real-world situations. The learning goal is we are learning to apply two-step equations to solve a variety of problems. Let's take a look at example number 1. Example number 1 does not have a picture. That's okay. Let's read it through first, and then we will go back in and dissect it. Cookie Castle sells 8-inch cookies for $3 each, plus a flat $5 delivery fee. Zach has $14 to spend on cookies. Write and solve an equation to determine how many cookies Zach can buy and have delivered. All right, Cookie Castle. Here we go. Cookie Castle is selling cookies, and they're selling 8-inch cookies for $3 each, plus, again, my colors aren't working, plus a flat $5 delivery fee. He has $14 to spend, okay? That's important to know. Can he spend $16 on cookies? Can he spend $20 on cookies? No. Write and solve an equation to determine how many cookies he can buy and have delivered. All right, so the first thing I want to talk about is this flat $5 delivery fee. A lot of times in real-world situations, you're going to have a flat fee or an initial charge. This means that no matter how many cookies he buys, he could buy 5 cookies, 10 cookies, 100 cookies. It doesn't matter how many he buys. He's going to pay $3 for each, but he also has to pay a one-time fee of $5. Okay? So again, if he buys 10 cookies, plus $5. 1,000 cookies, plus $5. That 5 is a one-time fee. It's like your shipping fee, right? It won't change depending on the number of cookies. So let's get started because we need to write and solve an equation to determine how many cookies he can buy. So, $3 each, okay? I don't know how many I can buy. So let's make X equal the number of cookies Zach can buy. So Zach has some cookies. And how much are those cookies? They're $3 each. How would I write that algebraically? 1 cookie, $3. 2 cookies, $6. 3 cookies, $9. $3 each is times 3. 10 cookies times 3, 30. 100 cookies times 3. 3 cookies each, plus that one-time fee, flat fee, means he only pays it once, of $5. Does the 5 get an X with it? No. That is an initial fee. It's a flat fee. It will not change. That plus 5 will always stay plus 5. So it does not get a variable with it because the number of cookies does not matter. It's only going to be 5. Okay? Equals, because I need an equation. And how much money can Zach spend on those cookies? $14, no more. So now we're going to solve our equation that we have just written to determine how many cookies can he get. So again, use what you know about two-step equations to solve this. How do I eliminate my constant of a plus 5? I'm going to subtract 5 on both sides. I bring down my 3x equals 14 minus 5 is 9. Now I'm at a one-step equation. 3 times x, the inverse is divide by 3. Divide by 3. So x is equal to 9 divided by 3 is 3. I'm going to go back to my original x statement. X is the number of cookies. So how many cookies can he get? He can get 3 cookies. Can he get a negative number of cookies? No. You can't have negative cookies. And let's just double check. I'm going to take my original equation and make sure that I have 3 correctly. So 3 times, I'm just substituting my answer into that original equation. 3 times 3 is 9. And what is 9 plus 5? 14. So we did it correct. Example 2. Again, no picture, that's okay. read it once all the way through. Jeff works at a warehouse, earning $17.50 per hour plus a $200 one-time hiring bonus. In Jeff's first week, his pay including the bonus, was $637.50. Write an equation and solve to figure out how many hours Jeff works in the first week. Okay, now let's go in with our pen. Jeff is working. He's earning $17.50 per hour. The per signals what operation? Multiplication. So per hour plus a $200 one-time hiring bonus. Sometimes when you get a job, they might be like, hey, if you come work for us, we're going to give you a bonus of $500. You don't get the $500 all the time. It's just that one time. As soon as you accept the job, they're going to give you that bonus. So right now, Jeff is going to get $200 just once. He doesn't get it every week. In Jeff's first week, his pay, including the bonus, was $637.50. So write and solve an equation to figure out how many hours did Jeff work. So that's our unknown. X equals the number of hours worked. Okay, let's get started on our equation. So let's start with his hourly pay. How much does he make? He makes $17.50 per hour, which we don't know how many. Per means multiply. He might work 1 hour, $17.50. 2 hours, $17.50 times 2. 3 hours, $17.50 times 3. Plus his one-time bonus. The one-time bonus does not get the X because it is not related to the hours he's working with. He only gets it once, it will stay $200, and he will not get it again. And how much, including that bonus, was in his paycheck? $637.50. There is our equation. Now let's solve. Let's eliminate the constant of the $200 by subtracting it on both sides. Remember to line up your decimals. So $17.50 X equals $637.50 minus $200 is $437.50. Now do the inverse operation and divide by $17.50. Divide both sides by $17.50, and you will get an answer of X equals 25. That means that Jeff worked 25 hours. Make sure you include words in your solution. Let's check. $17.50 per hour plus that bonus. His paycheck was $637.50. Let's plug our answer into our original equation. $17.50 times 25 plus the $200 bonus. Will that equal $637.50? Well, $17.50 times 25 is $437.50 plus his bonus will indeed give you $637.50. Yay! Example 3. Tracy's fitness goals. Okay, take a look. There's a table here. We have her planner. It has goals. A 20% improvement. 20%. We're going to have to use that. She's doing push-ups on Mondays, Wednesdays, and Fridays. She does them in the morning and the evening. What do we know about 20%? 20%, well, percent is always out of 100. If I simplify that fraction, that's 2/10. If I simplify that fraction, an equivalent fraction would be 1/5. 20% as a decimal is 20 hundredths, or 2/10, or 1/5 as a decimal is 2/10. So we got a lot of information, equivalent information, just by that 20%. So let's read the question. Tracy's fitness goal is shown on her planner. To meet her goal, she will need a total of 8 push-ups more than her current daily total of morning and evening push-ups. Tracy has been doing 25 push-ups in the evening. How many push-ups has she been doing in the morning? Okay, let's go back and read it through again. Tracy's fitness goal is shown in the planner. There it is. To meet her goal, she will need a total of 8 more push-ups than her current daily total of morning and evening. So we have AM plus her PM. And that has to have a total of 8, right? Total of equals 8. Tracy has been doing 25 push-ups in the evening. So let's put 25 in our chart. She does 25 here, 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 here. Okay? So in my equation, she does 25 in the evening. Do we know how many she does in the morning? No. And look, how many push-ups has she been doing in the morning? That's what we don't know. So I'm going to write my X equals AM push-ups. Okay, we need to define the variable. We don't know how many push-ups she does in the morning. We do know that she does 25 in the evening, and she wants 8 more than her current daily total. Okay, but her goal is 20% of that. 20% of this. So you can write 20% as a fraction. You could write 20% as a decimal. 20% of all of her push-ups, she wants 8 more than all of that. Okay, so now let's solve our equation to figure out how many push-ups does she do in the morning. Let me extend the page a little bit. Here we go. So do you like decimal or fraction? Which one do you like better? I'm going to do the fraction one just so I can show you for all my fraction haters out there. 1/5, oops, I forgot my equals 8. 1/5 of the quantity x plus 25, you're going to distribute that fraction. So 1/5 times x is 1/5 x plus, what's 1/5 times 25? Look, 1/5 times 25 over 1. We're really just doing 25 divided by 5, which is 5, equals 8. Let me erase this just to not confuse you. Now we're at a standard 2-step equation. Let's finish solving it. Let's get rid of that constant by subtracting 5 on both sides. I'm left with 1/5 of x is equal to 3. 1/5 of some number is equal to 3. Let's draw our bar model. 1/5 of a number is 3. So 1/5 is 3, which means all of these have to be 3, which means the whole number has to be 15. Or you can, this is 1/5 of a number, 1 divided by 5. What's the opposite of 1 divided by 5? Times 5. Or we can say we're going to multiply by the reciprocal. Don't forget that word, reciprocal. 1/5 times 5 over 1 gives us our 1x equals 15. That means she did 15 push-ups in the morning and 25 at night. Let's try some more writing and applying 2-step equations on our own.